Welcome back to the session on central difference interpolation formulae. In the previous classes, we discussed three central difference interpolation formulae, namely goes forward formula, goes backward formula and Stirling's interpolation formula. Here we shall discuss the fourth one, namely Bessel'S interpolation formula. Recall that if y0, y1, y2 etc. and y minus 1, y minus 2 etc. are the values of a function at equidistant points x0, x1, x2 etc. and x minus 1, x minus 2 etc. then by goes forward interpolation formula we have y is equal to y0 plus u c1 into delta y0 plus u c2 into delta square y minus 1 plus u plus 1 c3 into delta cube y minus 1 plus u plus 1 c4 into delta raised to 4 y minus 2 plus etc. Now, we know that delta y0 is equal to y1 minus y0, that is the forward difference. From this we can write y0 as y0 equal to delta y0 or y1 minus delta y0, y1 minus delta y0. Similarly, we can write y minus 1 as y minus 1 is equal to y0 minus delta y minus 1. Therefore, delta square y minus 1 can be written as, that is operating both sides of this expression by delta square, we can write delta square y minus 1 is equal to delta square y0 minus delta square of delta y minus 1 means delta cube y minus 1. Also, y minus 2 can be written as y minus 1 minus delta y minus 2. Operating both sides of this expression by delta raised to 4, we can write delta raised to 4 y minus 2 is equal to delta raised to 4 y minus 1 minus delta raised to 4 of delta y minus 2 means delta raised to 5 y minus 2 etc. In this manner, we can express all the higher differences. Now, in this expression, this is named as equation number 1. We split the alternated terms into two equal parts. Then we can write y as y is equal to this is y equal to y0 plus y0 divided by 2 or y0 by 2 plus y0 by 2. We split this y0 into two equal parts, y0 by 2 plus y0 by 2 plus u c1 means u into delta y0. Now, we split this term into 2, we get 1 by 2 into u c2 means u into u minus 1 by 2 factorial, u minus 1 by 2 factorial into delta square y minus 1 plus 1 by 2 into u minus 1 by 2 factorial into delta square y minus 1. We split this first term and then the third term into two equal parts plus next term is u plus 1 C3. U plus 1 C3 means u plus 1 into u minus 1 all divided by 3 factorial into delta raised to 3 y minus 1. Now, we split the next term into 2 equal parts. We can write this as first part is 1 by 2 into u plus 1 C4 means u plus 1 into u minus 1 into u minus 2 divided by 4 factorial. This is u plus 1 C4 into delta raised to 4 y minus 2. Similarly, the second split up of this term is 1 by 2 into u plus 1 into u minus 1 into u minus 2 divided by 4 means not 4 factorial into delta raised to 4 y minus 2 plus etc. Now, we just seen that y naught equal to y1 minus delta y naught. Delta square y minus 1 as delta square y naught minus delta cube y minus 1. Delta raised to 4 y minus 2 as delta raised to 4 y minus 1 minus delta raised to 5 y minus 2 and so on. Using these expressions for the second split up part, in this expression we can write y as y is equal to first split up is y naught by 2, which can be written as y naught by 2 itself, plus here 1 by 2 into y naught. For this second split up we use this result, y naught equal to y1 minus delta y naught, that is 1 by 2 into y naught minus y1 minus delta y naught plus u into delta y naught plus this first split up is 1 by 2 into u minus 1 divided by 2 factorial into delta square y minus 1 . For this part, that is for this second split up, we use delta square y minus 1 as delta square y naught minus delta cube y minus 1. We can write this as 1 by 2 into u minus 1 divided by 2 factorial into delta square y minus 1 is delta square y naught minus delta cube y minus 1 plus the next term is u plus 1 into u minus 1 divided by 3 factorial into delta cube y minus 1 plus the first split up of these two can be written as 1 by 2 into u plus 1 u minus 1 u minus 2 divided by 4 factorial into delta raised to 4 y minus 2 itself plus for the second split up we use the result for delta raised to 4 y minus 2 as delta raised to 4 y minus 1 minus delta raised to 5 y minus 2, that is 1 by 2 into u plus 1 into u minus 1 into u minus 2 divided by 4 factorial into delta raised to 4 y minus 1 minus delta raised to 5 y minus 2 plus etc. This is equal to, from these two we can write y naught by 2 plus y 1 by 2. That means y naught plus y 1 all divided by 2 plus here 1 by 2 into minus delta y naught means minus 1 by 2 delta y naught plus the next term is u delta y naught. Combining these two terms we can write u minus 1 by 2 into delta y naught. Delta y naught can be taken as a common factor. We can write u minus 1 by 2 of delta y naught plus, from this we can write delta square y minus 1 and here u into u minus 1 divided by 2 factorial is common. We can write this as u into u minus 1 by 2 factorial into here delta square y minus 1 divided by 2, in this delta square y naught divided by 2. Therefore, u into u minus 1 divided by 2 factorial into delta square y minus 1 plus delta square y naught all divided by 2. We combined these two terms. Next is 1 by 2 into u minus 1 by 2 factorial into minus delta cube y minus 1. Here also a term containing delta cube y minus 1. We can write these two as u into u minus 1 divided by 2 factorial, u into u minus 1 divided by 2 factorial into minus 1 by 2 plus u plus 1 divided by 3 into common factor is delta cube y minus 1 plus etc., which is equal to y naught plus y 1 divided by 2 plus u minus 1 by 2 into delta y naught plus u into u minus 1 divided by 2 factorial into delta square y minus 1 plus delta square y naught divided by 2 plus u minus 1 by 2 into u minus 1 divided by 3 factor. We can write this term as u minus 1 by 2 into u minus 1 divided by 3 factorial into delta cube y minus 1. The next term is this plus u plus 1 into u minus 1 into u minus 2 divided by 4 factorial into delta raised to 4 y minus 2 plus delta raised to 4 y minus 1 divided by 2. By combining this these two terms containing u plus 1 u minus 1 u minus 2, from these two we can write this term, this plus etc. Here this product can be written as u minus 1 by 2 into u minus 1, because u plus 1 divided by 3 minus 1 by 2 is u minus 1 by 2 divided by 2 into 3, and combining these two terms we can write like this. This is the expression for y. Y means y of x, that is y naught plus y1 divided by 2 plus u minus 1 by 2 into delta y naught plus u into u minus 1 divided by 2 factorial into delta square y minus 1 plus delta square y naught divided by 2 plus u minus 1 by 2 into u minus 1 divided by 3 factorial into delta cube y minus 1 plus u plus 1 into u minus 1 into u minus 2 divided by 4 factorial into delta raised to 4 y minus 2 plus delta raised to 4 y minus 1 all divided by 2 plus etc. This formula is known as Bessel's interpolation formula, which can be used to interpolate in the or the near the center of a given data. Now, if we draw or if we write the central difference table, we can observe that the terms involved in this formula, that means in the first term the difference is delta y naught, and in this this is an odd order difference. In the next term there are 2 even order differences, and taken as the average of these 2 even order differences, that are delta square y minus 1 and delta square y naught. In this term, this is delta cube y minus 1, which is an odd order difference, and in the next term average of 2 even order differences, and so on. If we draw a central line, that means a line about x naught y naught, which is the central line, then the terms y naught delta square y minus 1 delta raised to 4 y minus 2, which are the even order differences, all are lying in that central line, and the terms or the differences delta y naught delta cube y minus 1, which are the odd order differences, all are lying a line below the central line, and all the remaining differences, that are the term y1 and the even order differences delta square y naught delta raised to 4 y minus 1 etc., all are lying in the y1 line. Y1 line means a line through x1 y1, which is the observation from the difference table. Now, when we use this Bessel's interpolation formula, it is better to choose x naught such that the value of u, that is u is x minus x naught divided by h, lying between 1 by 4 and 3 by 4. If we choose x naught as the value of u lying between 1 by 4 and 3 by 4, we will get the better accuracy in the interpolating value. And note that if u equal to 1 by 2, this second term will become 0, and this fourth term will become 0, and so on. That is, the terms containing u minus 1 by 2 will become 0. That is, the coefficient of odd order differences will become 0, and this formula become y is equal to, y means y of x, which is equal to y naught plus y1 divided by 2 minus 1 by 8 into, here we put u equal to 1 by 2, means this is 1 by 2 into 1 by 2 minus 1. 1 by 2 minus 1 is minus 1 by 2. 1 by 2 into minus 1 by 2 means minus 1 by 4 divided by 2 factorial, that is minus 1 by 8 into delta square y minus 1 plus delta square y naught divided by 2 plus this term will become 0, and this coefficient will become 3 by 128. On simplification, this coefficient will become 3 by 128 into delta raised to 4 y minus 2 plus delta raised to 4 y minus 1 divided by 2, and the next term is minus 5 divided by 1024 into delta raised to 6 y minus 3 plus delta raised to 6 y minus 2 all divided by 2 plus etc. This formula is a particular case of Bessel's formula, which is suitable for interpolating at the midpoint of any interval considered as the interval x0, x1. Hence, the formula is known as formula for interpolating two halves, and this formula contains only the even order differences. Now, consider one example. Evaluate f of 2.73. Using the Bessel's interpolation formula, the given data is the values of x are 2.5, 2.6, 2.7, 2.8, 2.9 and 3. These are the x values, and the corresponding y values or values of f of x are 0.4938, 0.4953, 0.4965, 0.4974, 0.4981, and the last one is 0.4987. These are the function values. This is the given data. We want to find the value of f at 2.73. Note that 2.73 is near to this in this central value. Now, in order to get the better accuracy, we can choose x0 as 2.7, because the value of u in this case is u equal to, here x is 2.73 minus x0 2.7 divided by h. Here the interval difference is 0.1, 2.6 minus 2.5 is 0.1, which is equal to 0.3, which lies between 1 by 4 and 3 by 4, that is 0.25 and 0.75. Therefore, we can take x0 as 2.7. Now, substitute value of u and the relevant differences in this formula. We will get the value of f of 2.73. First of all, we form the corresponding difference table. This is the given data. The corresponding differences are, first is first order difference del f, or f means we can use y for f of x. Therefore, the first differences are delta y, which are 0.4953 minus 0.4938, which is equal to 0.0015. Next is 0.4965 minus 0.4953, which is equal to 0.0012. Next one is 0.0009 and next one is 0.007 and the last one is 0.30 and 6. The second order differences are delta square y, which are first is 0.0012 minus 0.0015, which is negative 0.30 and 3. Next one is negative 0.0003. Next is negative 0.30 and 2, and the last one is negative 0.001. And the third order differences are delta cube y. First is 0, then 0.30 and 1, 0.30 and 1, third one. The fourth order differences are delta raised to 4y, which are 0.0001 minus 0 means 0.000, 3 zeros and 1. This is 0. And the fifth order difference is delta raised to 5y, which is minus 3 zeros, 0.30 and 1. This is the corresponding difference table. Now, here x0 is 2.7, value of u is 0.3. Therefore, the differences or the terms containing in this formula are y0 and y1. x0 is 2.7 means this is x0, therefore, this is y0. So, y0 is 0.4965, therefore, y1 is 0.4974. These two will become in this first term. Delta y0 is 0.0009. In the next term, delta square y minus 1 and delta square y0, which are these two, minus 0.0003 and minus 0.0002. And in the next term, delta cube y minus 1, which is 0.0001. In the next term, delta raised to 4 y minus 2 and delta raised to 4 y minus 1, these two values. And in the next term, delta raised to 5 y minus 3. These values will become in this formula. Therefore, our required value is y of 2.7 or f of 2.7 equal to y0 plus yn by 2 means these 2 divided by 2, 0.4965 plus 0.4974 divided by 2 plus u minus 1 by 2 into delta y0 means 0.3, u is 0.3 minus 1 by 2, that is 0.5 into delta y0 is this value 0.0009 plus u into u minus 1 divided by 2 factorial means 0.3 into minus 0.7 divided by 2 into delta square y minus 1 plus delta square y0 divided by 2 means these two values, sum of these 2 divided by 2, that is minus 0.0003 plus minus 0.0002. divided by 2 into plus next term is minus 0.2 into 0.3 into minus 0.7 divided by 6 into 0.0001 plus 1.3 into 0.3 into minus 0.7 into minus 1.7 divided by 24 into 0.0001 plus 0.000 means 0 divided by 2 plus the next term is minus 0.2 into 1.3 into 0.3 0.3 into minus 0.7 into minus 1.7 divided by 120 this into minus 0.0001. On simplification we will get the value as f of 2.7 as this is equal to, that is f of 2.7 is equal to 0.4968 approximately. This is the required value. I hope that you have understood the formula. Thank you for listening this class. Have a nice day.